Our project is Chara 2.0, which serves as an improvement upon the current Chara system. As many of the students know, Chara is a web application for organizing student data in the UIUC CS department office hours. Students for various courses put themselves on the queue to get assistance from course staff in answering conceptual questions or specific logistics about their code. Now, the current Chara system presents many problems. Students may not alter any information about their location or question once they have made an entry without losing their spot in the queue. If they decide to move to another lab after dinner because Siebel is very crowded on a deadline night, then the TA may not be able to find them and they would be skipped. However, if they choose to change location, they would have to delete their position and move to the back of the queue. The improved system allows a student to maintain their position in the queue while altering other information as necessary. Moreover, we feel that gathering metadata about the flow of student demands would optimize office hour, staffing, and student waiting. That's why we have included data visualization about the flow of student demand and estimation for students on how long it is until their turn. Next, we will demonstrate the basics of how Chara 2.0 works.
So what we wish to do here is demo some of the basic functions of the user interface, and I will demonstrate the 3 basic functionalities in one go here. As traditionally, we would like to add ourselves to the queue for each class, so just select our course, then create our question, specify the assignment, and click Submit. There you go. Now, if we were very busy and need assistance in more than one course, then we could add a question to another course since it's a different staff. But we can really only have one active question per course. Now, here's the neat part. Let's say we came back from dinner and found our old lab space occupied. We resolve our own question but have a different one. The queue is packed, so we can simply update our location. We go here to click update and it will load a modal window. We change our information and voila, we have updated the TA where we are right now and we didn't lose our position in the queue. Now, if we don't have a question anymore, we could just delete ourselves and be done. Now, from the TA perspective, we can just log in and join to show that we are on duty. For each student, we mark them as having their question asked and in progress. And now we have to resolve it. We delete the student and we move on to the next one. And now we shall talk about the advanced features that will help the user experience from student and course staff.
The first advanced feature is a prediction-based algorithm that looks at various factors from the database and then predicts the overall waiting time among the students for each TA. This feature involves 2 parts, one of which was constantly loading information from the database as it was being updated. This part was a bit challenging as we needed to come up with an efficient way to load data each time. The other part was basically coming up with an algorithm which would predict the time properly and display it to the user. And this algorithm used basically the number of TAs at any given time, the overall answering time for each TA, and the average student asking time. The other advanced feature is looking at the overall TA distribution among various days and times. From looking at the distribution, we come up with a graph that displays all of the information in a really nice way. We also predict how many TAs will be there at any given point. And then this is also kind of based on just loading data, but in a slightly different way since we're looking at data over a period of time rather than as it is constantly updated.
One of the biggest challenges involved with doing this project was the uncertainty involved with what software would work and what would not. For example, at the beginning of the project, we tried using LDEP, but this could not work with Heroku, what we mainly used for our project. Other examples include trying to use several different Python APIs and then quickly realizing that they were not compatible with Heroku. This includes APIs even as simple as NumPy. The other major challenge involved in this project was the immense amount of time and preparation we had to spend in learning new software languages. For example, learning HTML and how to use Python to connect with the database was pretty challenging and time-consuming.